All right, let's talk about a word in Java that trips up pretty much everyone at some point: static. If you've ever just typed it out because a tutorial told you to without really knowing why, well, you are definitely not alone. So today, we're going to demystify it once and for all.
I mean, think about it. It's in the very first line of code most of us ever write, public static void main. But why? Why static? For a long time, it just feels like one of those rules you have to memorize, right? Well, I promise you, by the time we're done here, you'll know exactly why it's there, and it's actually going to make a ton of sense.
Okay, so before we can really get our heads around static, we have to back up just a tiny bit. We need to be super clear on one of the most fundamental ideas in all of Java: the difference between a class and an object. They're related for sure, but they are not the same thing. Getting this down is key.
And this is really the best way to think about it. A class, that's the blueprint for a house. An object, that's an actual house you build from that blueprint. Now, non-static stuff, think of that as the paint color on the walls. Each house, each object can have its own different color, right? Your house could be blue, mine could be green. Each object gets its own copy. But a static member, that's like a rule written directly on the blueprint itself. Something like all houses must have a front door. Every single house built from that blueprint shares that one single rule.
So here's the more textbook definition, but it says the exact same thing. The phrases you really want to lock into your brain are independently of any object and accessed before any objects are created. That's the superpower of static. It's all about the blueprint, not the individual houses.
Okay, that's enough theory. Theory's great, but seeing it in action is what makes it stick. So let's dive into some code and see how this actually works. We're going to look at the three main forms static takes. You've got static variables, static blocks, and static methods. So first up, static variables. These are basically shared data. Imagine a counter on our house blueprint that tracks how many houses we've built. That's a static variable. Then you have static blocks. This is code that runs one time and only one time, right when the class is first loaded into memory. It's perfect for any initial setup you need to do. And last, we have static methods. These are just functions that belong to the blueprint itself. They're like utility tools that you don't need an actual house to use.
Okay, to really see how this all fits together, we need to talk about the order of operations. This is where a lot of people get tripped up. So what we're going to do is walk through a piece of code, step by step, and see exactly what Java does and in what order when it encounters static stuff. I'm telling you, this is where the light bulb really goes on.
All right, check this out. The most important thing to see here is what happens before the main method even gets a chance to run. The moment Java loads this useStatic class, it does a quick scan for anything marked static. First, it finds static int a and sets it to 3. Bam, done. Then, it sees the static block and runs it immediately. It prints out that message and sets b to 12. Only after all of that static business is taken care of does Java finally say, okay, now I'm ready to call the main method.
And look, the proof is right there in the output. What's the very first line you see? Static block initialized. That's our smoking gun. It proves that the static code ran before anything in main did. So when we get inside main and start calling methods, our static variables a and b are already set up and waiting for us.
So now we've seen how powerful static can be, but it's not a free-for-all. There are some important rules, some limitations you have to know. And these aren't just random rules to make your life harder. They're there for a really good, logical reason.
Let's go back to our blueprint analogy. A static method lives on the blueprint. It doesn't live inside any one specific house. So if you ask a static method, hey, what's the wall color? It's going to say, I have no idea what you're talking about. Which house are you talking about? It can't access non-static stuff like wall color because it doesn't belong to a specific object. And that's the exact same reason it can't use the keyword this. This is a shortcut for this specific object I'm inside of right now. But a static method isn't inside any object. So know this for static methods. Okay, so that's how static members work inside their own class. But what about using them from somewhere else in your code? This is where they become super useful.
And here's the beautiful part. You don't need to build a house just to read the blueprint. You don't have to create an object to use a static member. You just use the name of the class itself, then a dot, then the member name. That's it. It's basically Java's safe, organized way of having global functions and variables that you can get to from anywhere without making a mess.
And here's a perfect example in the code. Let's say we have a class called static demo. It's got a static method callMe and a static variable b. Now, from a totally separate part of our program, we can just write static demo.callMe and static demo.b. We didn't have to write new static demo anywhere. It's clean, it's direct, and it's awesome for creating little utility functions that you need all over the place.
Okay, this slide right here, this is your golden ticket, your cheat sheet. If you ever find yourself getting twisted up about static versus non-static, just come back to this. It boils it all down. Who does it belong to? Static belongs to the class, the blueprint. Non-static belongs to an object, the house. How's memory handled? Static has one copy that everybody shares. Non-static, every single object gets its own copy. And how do you access it? For static, you use the class name. For non-static, you need an object reference. Simple as that.
All right, we've gone through a lot here. So let's zoom out and make sure we've got the single most important takeaway locked in.
If you remember nothing else, remember this sentence. This is the heart of it all. When a member is declared static, it can be accessed before any objects of its class are created, and without reference to any object. That's it. It exists on its own, tied to the class itself, ready to go from the very beginning. And that brings us all the way back to the beginning. The big question, why is main static? Well, here's the answer. When you tell Java to run your program, the Java virtual machine needs to know where to start, right? It needs an entry point. But here's the catch. At that exact moment, none of your objects exist yet. The JVM hasn't built any houses, so it can't call a method on an object that doesn't exist. It needs a method it can call on the blueprint itself. And what kind of method is that? A static method. The main method has to be static, so the JVM has something to grab onto to kick the whole program into motion. It's not just a rule, it's a necessity.
So the big takeaway is really simple. Static just means belongs to the class, not to an individual object. And here's the fun part. You've probably been using static members all this time without even thinking about it. Have you ever used the math class? When you type math.py to get the value of pi, or math.sqrt to find a square root, you never create a new math object first, do you? Nope, because those are all static members. Now that you know what to look for, you're going to start seeing static everywhere. So my question for you is, where else in the Java library have you seen it in action?